Welcome back, everybody. This is our fourth class in JEE Mains previous year questions for chapter Current Electricity. Before this video, we have made three videos in this series, and all of those videos are available on our YouTube channel. There is a dedicated playlist for this type of videos, so you can go to our channel and watch those videos out. We have also started similar series for NEET previous year questions, and those videos are also available on our YouTube channel's playlist section. So if some of your friends is preparing for NEET, then you can guide them through those videos. And if you find these videos useful, then do press the like button, share them as much as possible, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your donations, we will be able to keep on bringing you these videos on regular basis. So with this, let's start today's video. In previous video, I think we have covered up to question number 35 or nearby. So 34. That was last question, 34. And today we will start with 35. So let me adjust pen thickness and let's slide down the question to the corner. And here it is. The actual value of resistance R shown in figure is 30 ohms. So value of this resistance is 30 ohm. This is measured in an experiment as shown using the standard formula R is equal to V by I, where V and I are the reading of the voltmeter and ammeter respectively. If the measured value of R is 5% less, then the internal resistance of the voltmeter is. So we have to find out the value of internal resistance of the voltmeter. Now, as per setup, while or when we are measuring value of R, what actually we are measuring? In ideal scenario, what is considered that this voltmeter has an infinite resistance. That in ideal scenario. So let me write ideal condition. So what is happening in the ideal condition? In ideal condition, this diagram or this whole circuit looks like this. We have an ammeter, we have a resistance here, and we have a galvanometer here, because voltmeter is made of a galvanometer. And here resistance of this galvanometer is infinite, or we can say very high as compared to this resistance in parallel. And now we have here R. So this is our circuit in case of ideal conditions. So in ideal condition, their parallel combination gives us only R, and we measure potential difference across R. Now in practical scenario, practical case, this resistance is large but not infinite, and due to its certain value or some value, there can be changes in the value we measure across this resistance R. So here we assume that as per given in the question, that due to internal resistance of this voltmeter, there is changes in the measurement value. So what we do, we consider some value for this and then we do the analysis. So for that, ammeter stay as it is. We have some resistance that is small r, and we have a galvanometer here because their combination makes voltmeter, and we have a resistance r over here. Now, when there is certain fixed value, non-infinite value, then when we are measuring potential, then we are measuring potential across parallel combination of both of these. Here in a circuit, it looks like we are measuring potential across this R resistance only, but in reality, when this voltmeter has a certain fixed lower value of internal resistance, then we are measuring potential across parallel combination of both of these. So from this, their parallel combination will give us, say, total resistance RT, that will be 1 by R plus 1 by R. And we know that value of R is mentioned that in figure its actual value is 30 ohm. So its value is already mentioned, that is 30 ohm. So LCM will be 30R, this will be 30 plus R, and from this total resistance of this combination will be 30R into 30 plus R. Now, as per question, this value, this value is 5% less of actual value of R, or we can say this value is 95% of actual value of R. So 30R divided by 30 plus R is 95% of actual value of R, that is 30. Now this will go on 10. This will we do cross multiplication and we will get 100R is equal to 95R plus 95 into 30. From this 5R is equal to 95 into 30, get on 6 and 0, 54 and plus 3, 57, 570 ohm will be the right answer. Option B is the right answer. So you have to remember that whenever you are measuring potential with the help of a potentiometer, then you are measuring potential not across the resistance it's actually connected. You are measuring potential across the parallel combination of resistance of voltmeter and resistance of that resistance which you are measuring or you're thinking you are measuring. Now moving to next question. In the given circuit, internal resistance of 18-volt cell is negligible. So here its internal resistance is almost zero. R1, R3 and R4 are given. The reading of an ideal voltmeter. Look here, it is mentioned that ideal voltmeter. So ideal voltmeter's internal resistance is infinite. Across R4 is 5 volts. So here we are getting 5 volts. The value of R2 will be. So we have to find out the value of R2. Now for that, what we have to do, R3 and R4 both are in series. Then first of all, we will take their series combination, and then this series combination is in parallel with R2. So then we will take their parallel combination, and then we will take again their series combination with R1, and then we will solve the question, because we have to find out the current. If suppose there is some current in this branch, let's suppose that is I2, in this branch there is I1 and total current is I, where I is equal to I1 plus I2, and here current is also I. So we have to find out the value of I2, and then we will compare it with the value of R4, or we can say simply as value of R4 is equal to 500 ohm, and potential drop across its is 5 volt. So potential across it is 5 volt and its value is 500 ohm. And we know for any resistance, this formula, Ohm's law, always holds that V is equal to IR is always holds for a ohm, we can say a normal resistor. So here potential across this resistor is 5 volts. So 5 is equal to I times resistance, that is 500. So from this I, and this I is actually I2, because same current will flow through both of these resistances. So this is I2 actually. So I2 will be 5 by 500 or 1 by 100. ampere. Now we know the value of I2, and as I2 is following through both of these resistances, then we can simply replace them, both of these resistance, by their individual, or sorry, not individual, their series combination. So they both of these can be replaced by a single resistor of value R3 plus R4, and R3 plus R4 will be 600 ohm, and there is a current flowing through this resistance, that is equal to I2, that is equal to 1 by 100 ampere. And now this circuit looks like something this. We have R2 here and we have R1 here. Now we know value of resistance here 600 ohm and value of current, and by using both of these, what we can get, we can get potential drop across this resistance. So potential drop across this resistance will be V across 600 ohm will be I times R. I is 1 by 100 and R is 600. So this will be 6 volts. So potential across this resistor is 6 volts. And if this is 6 volts, then this is also 6 volts, because both of these R2 and 600 are in parallel. So potential drop across both of these resistance will be equal. So if 600 ohm resistance has a potential drop of 6 volt, then R2 will also have a potential drop of 6 volt. And now using this 6 volt value and the value of R2, we can find out the current through R2, that we denoted by I1. So from this, we can find I1, and let's find out that potential is 6, value of R2. Okay, we have to find R2. Okay, no problem. So yes, let's go to let's go to sideways. Now as we know that this potential drop is 6 volt, and total potential drop here is 18 volts. So if this is 6 volt, then potential drop across R1 should be 12 volts, because total potential is 80, out of which 12 is dropped across R1 and 6 is dropped across R2. Now if 12 volt is dropping across R1, then again V is equal to IR will hold true for R1. Now value of potential here is 12. Current we don't know, that value of R1 is 400. So from this, I is equal to 12 by 400, or we can say 3 by 100 ampere. So I is equal to 3 by 100. And from at this point, at this junction, we know that I is the incoming current and I1 and I2 are outgoing current. So for this junction, we can write that I is equal to I1 plus I2. And from this, I1 will be I minus I2. I is equal to 3 by 100 and I2 is equal to 1 by 100. So that's how we can get value of I1. So I1 is 2 by 100 ampere. Now again using Ohm's law, that V is equal to IR for now for R2. Now for R2 potential is 6. Value of current flowing through it is I1, and value of I1 is 2 by 100. 2 by 100 into R, that is R2. So that's how we can get R2 will be 300 ohm. Option A will be the right answer. Moving to next question. So here we have a combination of some combination of resistances, and we have to find out equivalent resistance between A and B. Now to solve this question, let's mark some point here so that we can understand this question easily. So A, B, C, D, E, F, G and H. So we sorry, A and B are already used, so let's make them P and Q. So let's see now. Here we can see that if you look carefully, let me use a pointer here. Sorry, not a pointer here. So if you look here, the connection between P, Q and E here, P, Q and E. Between P and E, there is a resistance connected, but between P and Q, there is a single wire. And similarly, between E and Q, there is a wire. So it means these points, point P, point Q, and point E, are at equal potential. They does not have different potentials. They are at equal potential. And if they are at equal potential, then it does mean that suppose that current is flowing from either A to B or B to A. So if suppose current is flowing from A to B, then and also here F and E are again this connection between F and E. This is a wire. Between E and Q, this is again a wire. And between Q and P, this is again a wire. As we know that when current flows, it takes the path of least resistance. So let's start from point A. From A to F, there is no other path other than passing through this resistance. But from going from the point F, we have a straight path. There is no resistance F to E, and again E to Q, there is no resistance, and again Q to P, there is no resistance. So effectively, we will have directly current going from A to B via only passing through this resistance and only this resistance. All other resistances will be bypassed because we have a short circuit over here. So we will ignore all other resistance and we will directly connect A and B, and our circuit will look like something like this. That we have A and this will be connected something like this, and all other resistances will be bypassed as we have a direct short connection between point F and point P. So this is F, this is P, and this is point P. So if this is R, this is R, then both of these are in series. So effective resistance between A and B is R plus R, that is 2R. Moving to next question. In the given circuit diagram, when the current reaches steady state in the circuit, the charge on the capacitor C will be. So we have to find out charge on the capacitor. As we have to find out here that charge on the capacitance when it reaches in steady state. So in steady state, capacitor is fully charged, and when capacitor is fully charged, there is a no current flow through it. No current is flowing through it. So in steady state, if no current is flowing through it, then R1 is disconnected from the circuit. So our effective circuit will be something like this. So this is battery, this is resistance R. Here we will have resistance R2, and here we will have this connection. Now, as no current is flowing through capacitor, so R1 and capacitor, we have removed both of them from the circuit for our calculations. Now we have a simpler circuit, and from this we can say that I will be equal to E by R plus R2. So this will be the current flowing in the circuit, and there will be no current through capacitor and resistance R1. Now to find out the charge on the capacitor, we know that charge on capacitor is given by C times potential, where is the V is the potential across it. Now, although there is no current flowing through this region or through capacitor and resistance, but still there is a potential drop across it, potential develop across it, and that potential will be equal to potential that is developing across this resistance R2. And that potential we can find out that potential across R2 will be current times resistance. So E by R plus R2 multiplied by R2. So this will be the potential that is developing across this capacitor. Now we can show the capacitance and the resistance. We know the potential across capacitor and we will know the value of C. So it will be Q will be C times E by R plus R2 multiplied by R2. So option A will be the right answer. Moving to next question. In the above circuit, current in each resistance is, so we have to find out current in each resistance. And as we can see from here that batteries are connected by 1 ohm resistance. Now, to solve such a system where we see some symmetry in the circuit, we can use, uh, suppose we take some point here or one of the point and assume some potential on it. Suppose this is point A and here potential is equal to X. Now, as battery is connected between, suppose this is point B, this is point C, this is D, E, and here we have F and G. Now, as battery is connected between A and B, so the difference between potential of A and B should be at least 2 volt in ideal conditions. So if potential of B is 0, then potential of A should be 2 volts, and vice versa. If potential of A is X, then potential at B should be X minus 2. Similarly, for point C, again 2 volt battery is connected, so here potential should be X minus 2. And as we can see from this, point B and point C are at same potential. So there will be no current flowing through this 1 ohm resistance. Now using same methodology for point D, as there is a battery of 2 volt connected between point B and D. So B point should be 2 volts, B point's potential should be 2 volts higher than D point's potential. Now, as per given, potential at B is X minus 2, so potential at D should be X minus 4. Similarly for E, and we can go further for F, it will be X minus 6, and for G also X minus 6. And we can see that D and E are again at same potential, so no current here again, and F and G again at same potential, so again no current here. So no current flows through the circuit, so option B, 0 ampere will be the right answer. Moving to next question. A 9 volt battery with internal resistance of 0.5 ohm is connected across an infinite network in the figure. All ammeters A1, A2, A3 and voltmeters are ideal. Choose the correct statement. So we have to find out, here it is mentioned A1. So we either have to find value of A1 or potential V. So we have to find value of these. Now, these type of systems, when we get infinite recursion of same value of resistance, like here 1 ohm, 4 ohm, 1 ohm, 4 ohm. So in these type of repeated systems, what we do, we assume that total resistance of the repeated system is equal to X. First of all, let's draw a simpler diagram of this circuit where we will only include resistance and not batteries. So we have been given 1 ohm, 4 ohm, 1 ohm, 1, 1, 4, and then 1 ohm, 4 ohm, then again 1 ohm, 4 ohm, and then keep on going. So we can see from here that this part of the circuit is keep on repeating every time. This part of the circuit is keep on repeating. Now what we do, we assume resistance of this whole repeating part is equal to x, and as it is on infinite repetition, as this part is on infinite repetition, then adding some value to x or subtracting some value from x will not change value of x, because it's on infinite repetition. So we can write like this, that we have 1 ohm resistance and 4 ohm resistance and 1 ohm resistance, and resistance of this whole repeating part will be, suppose, is equal to x. Now, as we already mentioned that this 1 and 4 ohm system is repeating again and again, and we can also see here that this is again 1 and 4 ohm system. So as this is infinite, repeating infinite times, their parallel combination with this 4, let me say it again in a proper language. I think I was not able to make it more clear. So as this system was infinitely repeating, so what we assume that resistance of the repeating part is x, and if we add some value to this x, then final value will again remain to be x, because this is an infinite recursion, and adding some value to infinity or subtracting some value for infinity does not change its value. So we are assuming here that its resistance is combined resistance is x. Then we will take parallel combination and series combination, and again that final resistance will again be equal to x, as due to infinite recursion. So their parallel combination will give us 1 by x plus 1 by 4. That will be 4x as LCM and 4 plus x. So this can be represented as 1, 1, and this is 4x by 4 plus x. So combined resistance will be 4x by 4 plus x plus 2, and this will be again equal to x, because this is an infinite series, and adding and subtracting something from it does not change its resistance, effective resistance. So now what we can do, 4x plus 8 plus 2x, 4 plus x is equal to x. So this will be 6x plus 8 is equal to 4x plus x square. Solving further, we will get x square minus 2x minus 8 is equal to 0. This can be further written as x square minus 4x plus 2x minus 8 equal to 0, and its factors will be x minus 4 plus 2x minus 4 is equal to 0. So value of x comes out to be 4 comma minus 2. So we take value of x is equal to 4. So total resistance of the circuit is 4 ohms, and this is only for the infinite repeating part, not for the internal resistance. So total resistance of the circuit is 4 ohm, and this circuit will be now represented something like this, that we have a battery here with internal resistance of zero point 0.5 ohm. We have an emitter here. We have a 4 ohm resistance here, and we have a potentiometer here. So whole circuit will look like something this. Now we can find out the current. So current will be, potential of battery is 9 volts, so 9 by 4.5. that will be 2 ampere. So value of A should be 2. So reading of A1 is equal to 2 ampere. And we can also find out the value of potentiometer, that will be 4 into 2, that will be 8 volts. So potentiometer will show 8 volts. Moving to next question. So six equal resistance are connected between points P, Q and R shown in the figure. Net resistance will be maximum between. So we have to find out that maximum resistance between 2 points. What will be the maximum resistance between any 2 points? So let's take point P and Q. Now for point P, Q, they are connected by resistance R, and they are connected by a series combination of these PR and RQ. So this is point P, this is point Q. Once they are connected by resistance R, and one between P and R, three resistance are in parallel. So they will be giving R by 3 resistance, and these two resistance in parallel will be giving R by 2 resistance. So and both of these are in series between P and Q. So here we will have R by 3 plus R by 2. Now solving this, R by 3 plus R by 2 in series will give us 5R by 6. So this will be 5R by 6, and this is R, point P, point Q. Now their parallel combination, so it will be reduced to 1 by R plus 6 by 5R. Total resistance between P and Q, RPQ. So 5R, 5 plus 6, 5, 11 by 5R, or RPQ is equal to 5R by 11. So this is the resistance between P and Q. Now calculate for PR. So resistance between P and R. Now we are going to calculate this. Now P and R connected by this R by 3 resistance and series combination of R and R by 2 resistance. So they will be, their diagram will look something like this. P, we have R by 3 here, and we have R plus R by 2 here, and this is point R. Now R by 3 and this is 3R by 2 are in parallel, so 1 by R of PR will be 3 by R plus 2 by 3R. LCM will be 3R, so 3 into 3 9, and here we have 2. So from this, R of PR will be 3R by 11. So R of PQ is greater than R of PR. And now moving to last one, that is QR. So between QR, they are connected by R by 2 resistance, and they are in parallel with series combination of R plus R by 3. So here we have Q, here we have R by 2 from the both of these, QR, and R plus R by 3 from here, R plus R by 3, that will be 4R by 3. Now 1 by R of QR will be equal to parallel combination, so 2 by R plus 3 by 4R, and that will give us 4R as LCM, and this will be 8 and this will be 3, so 11 by 4R, and R of QR is equal to 4R by 11. So PQ is the highest and PR is the lowest, and we have been asked maximum. So PQ is the maximum. Option B will be the right answer. Now let's move to one more question. A letter A is constructed of a uniform wire with resistance 1 ohm per centimeter. The sides of the letter are 20 centimeter and cross pedal in the middle is 10 centimeter. The apex angle is 60. The resistance between the ends of the lengths is. So we are here. It is mentioned that a letter A is constructed. So suppose this is letter A. This letter is constructed, and we have to find out resistance between two ends of the leg. So we have to find resistance between, suppose this is point P and this is point Q. We have to find resistance between these two. Some other details are that total length is 20 centimeter. So this total length is 20 centimeter and this length is 10 centimeter. And angle is 60 degree. So this vertical angle is 60 degree. So if we cut it in half hereby, so then this angle will be 30 and this angle will be 30, and if we extend this, this will make this side to be 5 centimeter. From using this, we can calculate value. Suppose this is PQ and this is S and this is T and this is W. So we have to find value of TS and PT. Their combined length is 20 centimeter. Their individual length can be find out as this is a triangle, suppose W, and we have used X. So we have a triangle something like this. This is point S, this is point X, and this is point T. This length is 5 centimeter and this angle is 30 degree. So we can say that ST sine 30, ST, that is hypotenuse, sine 30 is equal to TX, and that TX is equal to 5, and sine 30 is half. So ST is equal to 5 into 2, that is 10 centimeter. So this is 10 centimeter, this is 10 centimeter, this is 10 centimeter, and this is also 10 centimeter, and this is also 10 centimeter. Now, each centimeter has a 1 ohm resistance, as uniform wire has a resistance 1 ohm per centimeter. So we can represent this A into something like this, that each of part P, T, S, W, Q, as each part has a length of 10 centimeter and 1 centimeter is equal to 1 ohm resistance. So each part will have 10 ohm resistance. So this is 10, this is 10, this is 10, this is 10, and this is also 10. Now TS and SW are in series, so their series combination will give us 20 ohm resistance. So circuit will reduce to something like this. This is 20 ohm, this is 10 ohm, this is 10 ohm, and this is 10 ohm. Now 20 and 10 are in parallel, so their parallel combination will give us 10 by 1 plus 20, 1 by 20, 20, 2, 1, 20 by 3. So circuit will reduce to something like this. This is 20 by 3, this is 10, and this is 10. Now 20 by 3 is equal to 6.67. So total resistance will be 10 plus 10, 20 plus 6, 26.67 or 26.7. Option D will be the right answer. So with this, we end this video here, and hopefully whatever we have covered here till now is helpful to you, and will make your concept more clear. If you have any doubts, suggestion or comments, then you can put them in the comment section. I will try to implement them. Again, if you like this video, then do press the like button, share as much as possible, and subscribe to our channel. And at last, if you want to donate something, you can scan this QR code in front of your screen and donate us with whatever amount you want. Any donation will be appreciated. So with this, again, thanks for watching, and we will meet in next video.